5 times 5 is?
25.
Yeah. Hey folks, welcome out there. It's Mathline time, and I hope you're ready to hang around with us for the next, 25, 30 minutes. We have a great show coming from you. I am Ernie Roberts, and we've got a great show for you this afternoon. 844-686-2378. Those numbers, you know what those numbers are all about? That's the number we want you to give us a call on, all right? So hit those cell phones, hit those landlines, wherever you're calling from, 844-686-2378, and let us hear from you, all right? We have problems that we want to solve, but we want your problems to solve also, okay? So that's what it takes. Give us a call. You make the show rock. All those good things. Get your mind to doing it, all right? And I tell you what, get us started off and get you all thinking in terms of, let's get some problems going here. Let's check out our problem of the day. Problem of the day, boy, if you read this, you almost think, isn't that the same thing? But which cylinder has more volume? So we're looking at two cylinders here. One with a diameter of 6 inches and a height of 5 inches, or the one with a height of 5 inches. Excuse me, with that, I can get that right too, can't I? A diameter of 5 inches and a height of 6 inches. Oh goodness, let me try that again. 6 inches and height of 5 inches, diameter of 5 and height of 6 inches. Two different things. Boy, they are almost like a tongue twister. So let's talk about these two. Let's go ahead and get the promo off. Let's get going on with what we got here. So we are looking for, obviously, which has the most volume. So first of all, we need to talk about what is the volume of a cylinder. And the way we do a volume of a cylinder, we take its height, which is given to us there. Think of the tin can, okay? That's how it works up and down here. And we're going to multiply it. It's circular. The base is circular, so we're going to multiply it times that circle area. All right, and that circle area, by the way, is pi r squared. Now, in your textbooks, on your formula sheets you get for those state tests, those kind of things, they would probably go one step further and say, how about putting pi r squared h? And that works fine. There's no problem with that at all right? But it's sort of like doing a prism. The only difference is it's a round base. It's a circle instead. So again, it's the base area times the height. And by the way, the base area is this pi r squared times the height, and then we get a volume, which will be in cubic inches, all right? So let's check it out. See what we've got going here. First of all, they did throw another little catch at us there. These say diameters. We have to have radius. So first of all, don't go multiplying by 6 squared or 5 squared. We have a little bit of work to do before we get to that point. So first of all, we're starting with the diameter. We'll just kind of separate these things out, okay? Keep them straight. Heaven knows I'm having trouble keeping it straight today, aren't I? So we got D equals 5, and those are inches, so lovely. Over here, we've got our other little guy who's got 6 inches. So the diameter, the circle is bigger on our second can here, obviously, than the first one. But over here, we're compensating with a height of 6. That's this little guy here. And then we also got the other one where we got a height of 5. So what we're going to look and see is which combination. And again, there's your two diameters. There's your two heights. And basically, we were alternating the number. By the way, they're also inches. So there we have it. Ready to use the formula? I'm ready to use the formula. By the way, if the diameter is 5 here, which it was supposed to be, then that means the radius is 2.5. We'll put 2 5/10, 2.5 inches. Over here, we're going to put the radius, half of that. So we go to 3 inches. So that makes it a little bit easier to work with. The heights, no need to change them, all right? They're good to go. We're not splitting them or doubling or anything funny like that. So let's go to the formula. Remember what we got here. Volume equals pi. We'll go ahead and put the r squared, and then we'll multiply that height into there. Okay, remember that's the circle of the base times the height of the cylinder. This one over here, same story, same formula. Otherwise, we're not doing much good job comparing, are we? So we've got pi r squared and got that little h working for us again there. So it's now time, substitution, isn't it? We've got everything we need. You've got the h, you've got your r, cook it. And we know pi, well, we know pi is, for most of you, is going to be 3.14. But you know what? To answer the question, all you need to know is how much pi you've got. So this is really not going to be that very difficult, is it? Just square, multiply by h, and see what attaches to pi. That's easy, right? Easy. Everybody says, right we go. All right, so let's go back to it and let's put in what we know. We got pi. We've got r this time is 2 5/10, 2.5. We're going to square that, which all of a sudden that's where we get square inches coming into play. We're going to multiply then by the 6, which is they're going to take your cube to the cubic, all right, because these are all inches. These are square inches. This is going to be times another inch. You're going to have cubic inches, my friends, all right? So keep that in mind, lest I forget. And let's see, from our next point here, how about it? We're going to put in, the radius is 3. We will square that. Once again, those are those square inches coming your way. Times the 5, another pair of inches. So guess what? We've got cubic inches. So looking at what we've got, I guess you want to know what 2.5 squared is, or 2.5. I think it's 6.25. And we're going to take that times our 6. And for those of you who said, is it really 6.25? Well, let's find out. Oh, yeah, we got to have a pi, don't we? So we'll put a pi at the very end, kind of a little afterthought there since we've got it. Let's see what 6 times 6.25 will give us. Looks about like 37.5 with a pi attached, which was going to make it kind of crazy, okay? Oh, some of you want to know, did you really get 2.5 right? Yeah, let's look at that. 2.5, those of you versus my skeptics, we'll square it. There it is, 6.25, all right? So we'll move along. Now let's go ahead and play this next one. No question marks on our next one here, right? We're going to have 9 times 5, and that's going to be attached to our pi. So this time we got 45 pi. And these are in, remember, cubic inches. Cubic inches. And that is how we'll compare them. Obviously, looks like the one with the diameter of 6 inches wins out over the one that had a height of 6 inches, all right? So there's your story right there. Your height, they both influence the final outcome, obviously. It looks like that extra space in that circle did this one in. So where do we go with? Looks like we're going to go with the diameter of 6 inches and the height of 5 inches. Your very first one is your winner. By about a little over, it looks like, well, what do you think? About 7.5 pi. Let's see what it is. 45 minus 37.5. Let's see what happens there. I hope I got that right. Let's see, 37. Just for those of you who like to know. I do. Inquiring minds, they're always out there. Yes, 7.5. with a pi. So there's the difference there. So you do win out pretty good in that respect. And if you multiply it by pi, it's going to really pump it up there quite a bit. So now that's your problem of the day. Let's get some phones pumping here, all right? Let's pump that volume up. And we'd love to hear from you guys, ladies and gentlemen out there. That number, 844-686-2378. I know a lot of you folks are out there for the sick days and such, but still give us some calls, all right? Because I know there's still math problems going on out there all over our area. And plus the fact, I don't think in Middle Tennessee y'all have had the problems that we're having over here in East Tennessee with the flu and sickness. So please give us some calls, all right? 844-686-2378. We really, really would love to hear from you this afternoon. And you know, as I say before, you make the show rock. And rock it did yesterday. Anthony gave us a call. And I want to go back to Anthony's problem that he gave us yesterday, because I kind of left it in a point where, well, you know, did we really know it worked or not? Because some of you are kind of going like, ooh, that was a crazy looking fraction at the end. That value here, negative 40 and 8/9. Wow, pretty impressive answer. Well, the question is, would it have gone back and worked here? And folks, we were kind of rushed, I think, at the end, and I didn't know if we could get it all in, but we definitely can at this point in the show. But let's show that it does work. We got a y that was at, looks like a negative 40 and 8/9. So I'm going to go back and do this. I don't know if Anthony's watching today or not, but you're getting double mention, my friend, and thank you for calling this problem in yesterday. And what I'm going to do, I'm going to multiply that by this negative 40 and 8/9, which looks kind of crazy, doesn't it? And then we're going to add 48 times 16. And what we're hoping is this whole thing should give us, hopefully, 32. That's the big question mark, all right? If we put our numbers back into this equation, again, that's the way we check. That's the way we can check them. And you say, well, Ernie, that was kind of a big number. Well, let's remember, where did it come from? It came from this little guy right here. And yes, that's pretty much looks like what it's supposed to be. So let's check this thing out. We'll use the improper fraction form, negative 736 over 18 when we do our little substitution here. We're going to go to the calculator on this one, guys. This one's pretty rude, isn't it? That's the best way I could put it on that. It is pretty crazy, all right? So let's do that. Let's take our number 18 and let's multiply it by, are you ready for this, folks? How about it? We're going to multiply it by negative, and there's a negative in there, 736. We're going to divide that by, what do we have by 18, I believe? All right. And then we'll close that parenthesis because we don't want this to keep going. Put a plus, and we'll put 48 times 16. Don't really need a parenthesis here because we're doing it all in. And I think, honestly, because the order of operations, you would have multiplied and then divided, so that part really didn't need one either. But we put it in there just for safekeeping. And look what we get, 32. So, Anthony, it worked great for you yesterday, all right? So that one checked out. That's the biggest thing, because we already knew X was 16. He gave me that answer yesterday. So again, we did a little bit of substitution and had to find the Y. Boy, that was a rough one to come up with, all right? But then we had to make sure that 32 was what we got back when we put in the 16 and we put in that crazy negative 40 and 8/9. So, Anthony, thank you for calling in on that one yesterday. And folks, let's do some things like Anthony did yesterday. Give us a call. That number is 844-686-2378. We would love to hear from you. Close out this week with a lot of good things going on, all right? And it is. It's Thursday, and for us, it's pretty much almost the close of the week, although we do have specialized segments coming your way tomorrow, and it's going to be a pretty good one. It's all about rectangular solids, and there's some problems that are pretty easy to follow, and there's one at the end, it's going to challenge you a little bit, all right? So you don't want to miss out on that. Do a little algebra and your geometry mixed in together on the very last problem, but don't miss out on the front end either, because it gives you a little practice on surface area of the rectangular solids. So a lot of good things. Sometimes they're called right rectangular prisms. So be sure you give us a look tomorrow. Sit down and set a spell with it. Do some math with us then. And by all means, give us a call today. 844-686-2378. Now, we have been running a little thing called Problem of the Week. And today is it, the last day of the week. So let's look at this thing and see how we're going to work it out. We're going to finish it off today. Thus far, just to refresh your memory, we're talking about the floor plan of a room being drawn to a scale where 1/8 of an inch equals a foot. So keep in mind, the plan is much smaller, obviously, because it's on a scale versus what we have. Could never really create that room. It's almost like bigger than the room I'm in right now here. So you want to be sure, that you understand that's what's going on. So this room is much, much larger, obviously, than that. It's like a little miniature is what we're drawing there, a little scale. Now, the plans measure, according to this, 1 5/8 inches. So there's one dimension, and we did a little work with that yesterday. We changed that into 13/8. We also worked with this little guy and said that was going to be 11/4, because perhaps something in there might work for us. And we also noticed an important little fact here, that if we went to a full inch, which by the way we do have here, that would tell you, you've got 8 feet in 1 inch. Now how do we figure that out? It's a scale. It's a scale. In other words, if 1/8 of an inch is equal to 1 foot, then if you multiply through by 8, you're going to have 1 inch actually equaling 8 feet. So there is what's going on. So we could do a couple of things on this. We could play a proportion, which would be 1/8 equals to 13/8. And we'll put an X down there because that's what we're trying to do, is figure out how many feet. All right, this is 1 inch to foot proportion. And when we cross multiply, this is going to really come out easy because X and 1 line up nicely. So we've got X equals, and we got 8/1, which I will say, times 13/8. Do you see how easy this one worked? My goodness, it's X equals 13 feet. So that goes with the 13 inches over 8, or 1 5/8 inch. There's your dimension right there. It goes to 13 feet. How about this one? Is it just as easy? Well, we got 11/4, but let's go ahead and do that. We're going to keep the same ratio. Let's see if I can find space here. We've done a lot of room, haven't we, folks? 1/8 equaling 2. Let's do this time 11/4. And we'll put over Y so we don't get it confused. Cross multiply. Again, we get y equals that 8 over 1 times 11 over 4. We'll kick it out. We can cancel a little bit. I'm getting 22. And by the way, that transitions to feet. Because remember, this is 1 inch to 8 feet. This is 1 inch over here to 8 feet. All right. So there's your dimensions, 13 and 22. There you go. Problem of the day, problem of the week. This was a problem of the day last week, but we had a snow out, so this became a problem of the week, and we did very well with it, all right? And Denise out there on Facebook, congratulations, you had it right. You did say 13 by 22 today, I noticed. So others of you may have got me. I just didn't get out there to look at you right before the show. So anyway, thank you for participating on the problem of the week. Now, let's get down to business. It's a day, right? It's Thursday. Need to hear from you guys. 844-686-2378. Give us some calls, all right? We're kind of sitting here not twiddling our thumbs, but we sure would love to be talking with you, all right? We'd love to have you calling in and talking to you about the math problems that you have for us to work out together live on the air. Now, while we're waiting for you, we do have, I think, a Hey Mathline waiting in the wings. So let's see what we got there, Connor.
Hey Mathline, this is Emily from Bearden High School in Knoxville, Tennessee. I need to solve the equation x minus 1 raised to the 2/3 power equals -4.
All right, Emily, thank you for that question coming here from Bearden High School. Looked like she had a good day today. I mean, it's a beautiful day out here too also. Let's see, we're going to solve an equation which has a, whoa, y'all got that? It's going to have x minus 1, and we're going to raise that whole thing to the 2/3 power. So what does that mean, Ernie? It's a fraction, isn't it? Ooh, it says there's some good stuff going on in that. Lots of ways to interpret that, actually a couple of good ways. And we're going to say it equals to -4. And what we want to do when we have a fractional exponent in this situation, and we basically need to get rid of it, because like most of you went, what, 2/3? I do the same thing. What, 2/3? So how do we take care of little things like that? Well, here's where we're going to go on it. We're going to take and we're going to raise that power to where we can get it to a 1 power, all right? And how do we do that? Well, we multiply by the reciprocal. And by the way, that's our rule for exponents, is basically the whole, we got a big bracket here because everything, this thing is going to take care of, we're not breaking this down. In other words, x to the 2/3 and 1 to the 2/3, that's not what that means. It means the whole parentheses got to work together. So we're going to take care of this exponent right there. But as many of you are going so quickly and saying, oh, but Ernie, you got to do it to the other side too. Which now brings me to the point. Emily, I hate to tell you, but I think your problem is not going to have a real solution. It's not going to have a solution the way we're working it at all. We're going to have a problem. You say, well, Ernie, what's the problem? What this tells me, and let's go back to what these fractional exponents mean. This little 2 down here means says we're going to take the square root of whatever number is in my parenthesis. Well, my friends, we happen to have a -4 there. Oh my goodness, you can't take the square root of a negative number. You get imaginary, you get complex roots, and we're trying to solve this equation to get real roots out of it. So we're not going to go into the heavy duty, and I think, Emily, you just kind of gave me one of those that said there's no real number, no real solution, but we're going to work one in just a minute that will have that. So basically, you say, well, what do? Y'all want to believe me? All right, let's go take a look at it. Let's put it on the calculator. Why not? You say, well, what? Why doesn't it work? Well, let's see. Calculator knows it doesn't work either. It better. So here we go. We're going to put 3, and we're going to divide that by 2. That's the exponent. And what it's going to say is going to be an error. And it's going to say no real solution or something of that nature. Your calculator's pretty smart. Yeah, non-real answers, we can't do that. In other words, you can't do that. In real mode, and that's what we're playing with here, all calculations must result in a real number. So let's clear that out, and let's see if we can do a minor adjustment. By the way, let me finish it off what this 3/2 means. This would mean take the square root, and then you would take that and raise it to the 3rd power. So if we were able to get this, but the problem is when we start looking at the square root of a -4, we've got plus or minus 2i, and then we got all sorts of messy things, and we're not going there, all right? Because then we got to raise that up to the 3rd power, and things get messier and messier. Let's just do one important thing. Emily, appreciate you so much on that question, but let's do this. Let's keep x minus 1. That part's fine. 2/3 is fine. We'll be okay. What we are going to do, though, is pull that down just a little bit. We're going to let it go to a positive value because that's where the problem happened. It's where the error occurred. So let's go with that, and let's do what we said we would do. We're going to raise it to the 3/2 power. Again, reciprocal of the power will take care of this. So we've got 2/3. We'll put the 3/2 right there. Boy, that gets kind of crazy, doesn't it? And we'll also do 3/2 there. And I'm telling you what, I'm just taking my picture out over and over here, but you all probably don't mind. Let's see what happens here. We lose the 3's and the 2's, and we're left with x minus 1. Now that part was good. Remember I said it was okay over here. That's not a problem. Now, can we do 4 to the 2/3, or 4 to the 3/2 power? We could also do 4 to the 2/3 power if we had to. But let's take the square root of 4, which is nice. That's 2. And let's raise it now to the 3rd power. You say, whoa, that was a quick move. Well, that's what that means. So what do we got, my friends? Talk with me here. Think with me just a second. It sounds to me like we have 2 times 2 times 2, which is 8. I believe that's it. Square root of 4 is 2. Raise to the 3rd power. We got an 8. And now we have something really easy to work with here, all right? Marquez would be jumping on this one right now, okay? And he would say, we're going to add 1 to both sides, and that's exactly what we're going to do. And now we've got x equaling to 9. Now, for those of you who are probably wondering, Ernie, does it really give us that, what you said? Let's try it. 4 to the raise it, we're going to raise it to the 3/2 power over here. I love my non-believers out there. Let's see. And we'll put it divided by, because that's the way it works. And there it is. It gives us 8, which is what we had. Now, let's take a look at what happens back to the original equation. Not this one. We're forgetting about that one. This one is what we're going to go back to. So we're going to have x minus 1. We'll raise that whole quantity to the 2/3 power. And we're going to check. Does it equal 4? And this is another lesson in these fractional exponents for everybody. All right, so I hope you're hanging with me here on this. If you put 9 minus 1 in there, you're going to get 8, and we're going to raise that to the 2/3 power, which does equal 4. So here's what this is telling me. Take the cube root of 8, whatever's in that denominator saying what nth root we're taking. Over here, it was just simply the square root because it has a 2. This one, we're taking the cube root. If it had a 4 in there by some chance, we'd be taking the 4th root. You get the idea. We can take the cube root of 8. It's going to give us 2. And then that tells you how high up you raise it, which is basically saying, what it's basically saying here is we're going to take the cube root of 8. We're going to square it. And that, dear friends, is going to give us, you know what it's going to give us? How about it? It's going to give us 2 squared, which gives us 4. 1 check. Now, let's check another way. Let's go back to this 8 to the 2/3. Because I know some of you probably, that's not an 8 2/3. That is 8 to the 2/3 power. Another way we could do that is to go ahead and say, what is the cube root of 8 squared, which is 64. And my friends, if you go through and find out the cube root of 64, you also get 4. So a couple of ways to check. And basically, what we're doing on this thing, and you could have split up the deal on the exponents. I just took it out in one lump, okay? Because that's the way I like to do it a lot of times. Just move things along and see where they go. But there you have it. 4 and 4, it does check. Emily, except for that negative, but I appreciate that question because we got to see a no solution with this one. Then we got to fix it. And not necessarily fix it, we got to come up with a situation here. I'm about to say system, it's not really a system. A situation that actually does have a solution and a couple of ways we could check it. So you did well. And Bearden High School, thank you all. They help us out in a lot of ways here on Mathline. And we hope that your schools will join us out and do the same kind of things, all right? Now, what's coming up the rest of the week? You say, well, I didn't have any calls today, but that's all right. I hope you all who tuned in got a little bit of maybe a little moment with those fractional exponents. That's an Algebra 2 type situation. And a little bit of honors Algebra 1 probably thrown in there too. But nonetheless, picking up, some of you wonder, where are they going to use that? Well, they'll use it some. Square roots and cube roots are all around, and powers and all those good things. But tomorrow, what we do have tomorrow, we have the specialized segments coming your way. And it's a good show. It's a great show, I think. It's based on surface area of a rectangular solid or a right rectangular prism. Whew. Don't say that too many times. You might get all sorts of words coming out of your mouth. But it's a good show. It's a good stuff there. We're going to talk about surface area, like you're wrapping things up for Christmas presents and things like that. And my goodness, going to use square inches all around because it's area, all about the area tomorrow. And also, of course, we got the Facebook still going on. We want you to check us out on our problems of the day there. Also with YouTube, we are still taking good care of you. We're showing our shows. We're showing our problems of the day. We want you to like and share us on those things and subscribe on YouTube. Subscribe on YouTube and on Facebook. Keep that liking, keep that loving, keep that sharing, and everybody get well, all right? We want to hear from you next week. We're going to be back live again. And until then, we will see you next time.